So today's topic is backtracking. What is backtracking? It is basically a recursive technique to build a solution incrementally. Backtrack as soon as you determine that the current path won't lead to a valid solution. That means if we get some solution, let's say we get we are having 1 2 3 as the array, and adding one of them we got at the last 1 2 3, right? First we will add 1, then 1 2, then 1 2 3, right? Like this. Now we know after this we can't go further, right? Now we will backtrack. We will remove this 3 from the result. Again we will backtrack. We will remove this 2, right? So that's it. And here we will be adding 1 comma 3, right? To make a different solution, another solution. This is what backtrack. We are doing what? We are removing the element from the result. After the recursive call is completed, we are removing it. That's called backtrack. We are going back, right? We are tracking back. That's what a backtrack, right? What is the key idea? Try a possibility. If it doesn't work, backtrack, try the next one. Okay. And repeat until a solution is found or all possibilities are exhausted, right? That's what I said. We will go down till we reach the end of the loop or the array, and then when further we can't go, right, we will remove the element and go back. We will backtrack, right? This is what backtrack. And what are the steps to solve using backtrack? We will choose an option from a set of valid options. We did that. We choose 1, then 1 2, then 1 2 3. After that, explore, recurse to explore further using that choice. Okay, we chose this 2, we chose this 3, correct? After that, undo the choice, backtrack. This is called backtrack. Undo the choice and then try another option. We are excluding this 3, we are excluding 2, then we are adding 1 3. This is different set, right? Understood, guys? This is the definition basically. What is the definition? We will try a possibility. If it doesn't work or we got some solution, then we will backtrack it and try to find the next solution, right? And repeat until a solution is found or all possibilities are exhausted. And these are the steps. First we will choose, explore, and then unchoose. So this is just an additional step to what? DP, right? At the end we are doing what? We are removing the element from the result. We are backtracking, right? So when to use backtracking? When problem requires all combinations, permutations, subsets. Okay, subset is important topic or important question, we can say. Problem involves decision making at each step, yes or no, pick or skip, right? You see constraints like must, not repeat, must be unique, follow specific rules. So we will see some questions. First one will be the subset only. The second one will be for the decision making, right? Either yes or no. And we need to find all the paths. Great. And you are asked to generate all solution or a valid one among them. Correct. So there are some common questions and queens. There will be queens and we need to find their places. We need to find their places on the n by n chessboard. Sudoku solver, subsets. These are some basic common examples for this backtracking. Now, how this backtracking works? Let's see the example. Okay, so I explained you this example, right? 1 2 3 1. We are doing what? We are calculating the subsets, right? 1 2 3 is the subset, 1 2 is the subset, 1 is subset. When we are backtracking, we are removing 3, we are removing 2, then we are adding 1 on the same. 3 on the same. This is one of the subset, right? So let's check this question. So let's understand this subset generation. We need to generate all of the subsets. Okay, this is the given array, this is the given numbers. So what can be the subsets? Empty array first, right? Nothing, we will choose nothing. Then 1, then 2, then 1 2, right? These are the possible subsets for 1 and 2, right? So let's start. So initially we will be at 0 index, right? We are at 0 index. So we will add this 1. Initially we will adding the empty one also. Okay, adding also, adding in result. Okay, in result, this also we will add. Then we will call for the next index, that is 1 2. Now we will be here, right, and we will pass this result as it is. So we will be adding this element now, 1 and 2, right. This is new subset, we will add this in the result. Okay, till now we got 1, we got 1 2, right. After that nothing is there, right. We will go backtrack, and while backtracking we will remove this 2, right. Now we are at 1, After that, what will be the second condition? Second condition will be, we will not take this one, we will simply move to the second one, right. That is 1 and 2, we will move to this 2, that is we will get this 2. Okay, basically what we are doing, again we are backtracking and we are removing this one, right. After that we are adding 2. Got it? Now again we will add this, we got 2. First we are going in the depth, we are keep adding the elements, making the subsets. Then when we can't go further, we will do backtrack, and in the each step we will remove the last element from the result, that is 2, then 1, right. Then when everything will be completed, then we will go to the next index, that is 2, and we will add this. If it's clear, shall we code it? Okay, and with the code I will explain you one more time. So 1 2 is given, right. So let's start the backtracking function. So what we need to track, basically we need to track the index first of all, right. We are at this index or this index. After that we need to maintain the the current result, right, and the main result, in which we will be adding these subsets, correct. After that, this nums also we need to maintain, right. We need to pass in every call, recursive call, nums. That's it. Yeah, I think yes. Okay, so let's call the backtrack. So backtrack, what we are having, the index, the current index, right. After that the nums, yes, nums we can have. After that this current result, that will be type of list, integer, current, and the main result, that will be list of list, right. List of integer, and the name will be result, right. So that's all. After that, what we will have, now we will be adding the result. Let's say first we are adding the empty string, right. So we will be calling this backtrack with the 0 index, and the empty list, right, initially. So nums empty string new array list, this will be the call from the main function, right. This will be the call. Now first we got this empty list, so we will add this. At each call we will be adding our subset. If you see here, at each call we are adding this, we are adding this. So at each call we will be add this. Result dot add new array list. What we need to add? This current, right, CURR, right. So we are adding the current subset, right. After that what we need to do, for each index we are going further for the next index, right. So we will be having one for loop. See, we need to verify, we need to get all of the pairs, right, with all of the elements. Let's say we are having 1 2 3, right. So we need to get 1 3 also, right. Basically we will be traversing the for loop and again calling for the next variables. Are you getting it? So using for loop we can do that. I will explain you with the example also afterwards. So int I will be this index, okay, from where we are starting. After that I should be less than nums dot length, it should be within the bounds. then I plus plus. Correct. After that, what we are doing, we will just add the current element in the current list, right, in the current subset. So current dot add nums of I. So we are adding the element, right? So when we are at the first position, that means the first call, what we are doing, we are adding this first element, that is 1, right? So same thing we are doing. After that we will be traversing the elements, the further elements, that is 2, right, the array elements, to make the combinations. Then we will be taking the next element, right? So let's call the backtrack function again, with what index will be I plus 1, right, I plus 1, the next index, the next element, current nums, then current, then result, right? That's it. So what it will do, we are having 1 and 2, right? First, in the first call, when we are having empty this current list, it will add 1, right, in the first call itself, right? We are adding it. After that, it will call for the next, that is I plus 1, this one, right? So initially it will be I, in the call itself we are adding this element, right? So it will be 1 and 2. Great. Now after that we can't go further, right? If we go further, it will be out of the loop. We can't go inside the loop, so it will come back, right? We will call for the 1 2 here after the bound, so it will go back. What we need to do now, it's completed, we will be backtracking, right? Remove this element. So current dot remove last element, right? So it will be current dot size minus 1, and that's it, right? That's it. So when we are at this point, it will remove this, right? It will remove 2 and will go up, right? Because this call is also completed, right? After that we are at got it, guys? So basically the role of this for loop is basically to create each and every possible combination for all of the elements, for all of the cells, we can say. Clear? What is the time complexity basically here? What is the time complexity for finding the subsets? Basically what we are doing, we are recursively calling each and every element and we are checking each and every combination. So it will be 2 raised to power n time complexity, right? And within this we are having this for loop, so it will be 2 of n multiplied by n, right? In the worst case, this is the time complexity for finding the subsets. Let's check the question then. This is the question. Consider a rat placed at position 0, 0 in an n into n matrix. The rat goal is to reach the destination at position n minus 1, n minus 1. Basically the rat is at the top position and it want to go to the last position, and he can move in 4 possible directions, that is up, down, left and right. So the matrix contain only 2 possible values, that is 0, this is the blocked cell, so we can't travel through this, and 1 is 1, a free cell, we can pass through it, right? So our task is to find all possible paths that the rat can take to reach the destination. Now we need to find the all possible paths. Wherever you get this term, you will apply the backtracking, right? So what is backtracking? We are checking one path. If it's a valid path, then we will add it in the result, then we will go back, we will backtrack, we will remove that path, right, and check the different path. Got it? So under the condition that the rat cannot revisit any cell among the same path. Okay. Furthermore, the rat can only move to the adjacent cells within the bounds, so it should be within the bounds and not blocked. So let's see the example. So we are given the matrix as 1 0 0 0, then 1 1 0 1, then 1 1 and 0 and 0. Last one is 0, 1, 1 and 1, right? Now what are the valid paths from here to here? One path is we can go from here, right? One path is this, one path is this, right? So there are two paths, and which are what? D, D, R, D, R, R, right? First we will go down, then again down, then right, then again down, then right, then right, correct? This is the one path, right? What is the second path? Second path is D, R, D, D, R, R, right? So we will go down, then we will go right, then down, right and right. Great, correct? So these are the two paths, right? How can we do this? We will apply backtracking, right? We will apply backtracking using DP. We will find a way. Let's say this way, correct? We reached here. Now when we reached here, we will backtrack, right? We will backtrack. What we will do? We will go back here, again check if there any other possible path. No. Go back, nothing is there, right? Go back. When we are here, we will check this path now, right? This, then we will check this, and that's how we will get the second path. Understood? Basically we need to check for 4 conditions, right? So we will call for the 4 conditions at every cell. Then the base condition will be if our row and column is the last one, that is n-1 and n-1. At that case, we will be adding the current path. What is the current path? This will be the current path, right? We need to maintain this one, correct? We will add this in the result, right? In the result, when we will add, we will return it. After returning, we will do what? We will be removing this last one, right? Or in the call itself, it will remove, right? In the recursive call, we will check this. After that, we need to do what? We need to also maintain one visited array here. Okay, so that we should not go, see, if we are at this index, right? We will check here, right? We will also check here. We will also check here. We will also check here, right? 4 directions. Now, let's say from here, I checked here. This is completed. Now, I checked here also. This is also completed. Now, I should not visit this again from here, right? From here. So in that case, we will be applying using visited array, so that if this visited array is completed, that means we should not traverse this path again, right? And when we backtrack, this will be true. This will be true in the visited. We will make it false. False in visited, right? That means this is not visited yet in the new path. Got it? So 2 things we need to backtrack. One is this result, that is direction result, right? The second thing is visited array, this result and the visited array. So you understood, right? For every BFS call, let's write the steps. Okay, so what should be the steps? First step should be start from the 0, 0. That means the first index 0, 0, right? The second step will be explore all directions, all 4 directions, all 4 directions. For this, we will be having one directional array, right? Array, like what? We will be having one x, one y. With that, we will be having the direction. Let's say this is down, so we will say D, because we need to add this D in the result, right? So we will be using from here only, right? So this is the second step. What is the third step? If the next cell is in the bound, right, and not visited, right, and What else? Is not block, right? So we will process further, move to the fourth step. So these are the conditions we need to check. Next step, we need to check for the bound condition. It should be within the bound, greater than 0, less than n. It should not be visited, it should not be blocked, right? So we will proceed further to the fourth step. What is the fourth? We will check what? The base condition, right? If we call this, we will proceed. We will call the backtrack function again. Now the condition is if we reached last, that means n minus 1 row and column, right, at this path in the result, correct? This is basically what? Base condition, right? Base condition. After that this call is completed, it will go back and we will backtrack, and two things are there for backtrack. We will remove the direction from the result, and we will do what? We will make this visited as false, this current cell, right? 0 index, right? We are at 0 index. From 0 we call this 1, it's completed, so we remove this 2, then we are again at 0 index, right? So again it will remove the last element, that is 1, right? 1, right? And then it will go in the for loop, call for the next index. Now index will be what? I will be 1, right? From 0 it will go to 1, then add the 1, the element at the 1 index, right? So we are adding 2, right? After that again it will call the element that will be out of the bound and come back. Understood the steps? Okay, let's code it. So we are given this function, we are given the 2D matrix. Now let's first take the n, the size. After that the result will be there, right? Type is string, which we need to return. Error list. Then what else? Visited array, yes, boolean visited of size what? N into n, right? We need to have a 2D matrix. After that what else? Now we will start the backtracking call, right? So we should start if our first element is not blocked, right? That means first should be 1, right? If maze 0, 0 is equal to 1, that means proceed further and we will call the backtracking. Now in the backtracking, what we need to maintain in the call, in the backtracking call, what we need to maintain? First one is this the indices, right? I and j, right? The second one is the maze will be there, the grid as it is. Third will be the, let's say, the string, right? The result, current path result, right? So here we are not adding it in some string or array. We are just maintaining this here in the call, right? So no need to delete something or remove something, right? If we go up, it will automatically be removed, right? Fourth part will be visited array. Fifth part will be the result, right? Correct? Yes. And let's also take size. So if it's equal to 1, then we will call the backtrack function, in which I and j will be there. That means 0 and 0 initially, right? We should start from 0 and 0, then maze, then let's say size of this. After that the visited array, let's say visited array. Okay, then the result, and one more thing should be there, what, the string, right, the string, the resultant string, right. So let's write the backtrack function. So backtrack int row will be this first one, the column will be second one, what else, the maze, int of int maze, right. After that n is there, size, after that this current string, so string path, current path, right. After that this boolean 2D array visited, then last one is list, I think, yes, list of string, correct, and name is res, right. So what we need to do here, first we will check the base condition. What is the base condition? If, what was the base condition? If we reach the n minus 1 and n minus 1, row and column should be n minus 1, right. If row is equal to n minus 1, what is the second condition? Column is equal to n minus 1, then what, then we need to do what, we need to add this path in the result. So result dot add path, right, and after that return from here only, right. So what's next? Now we need to traverse for every cell in 4 directions, right. So we will be having 4 directions. Let's make the array, int 2D array will be there, directions, I think you remember how we make this direction array. So for 1 and 0, that means the down one, we are increasing the row, column is same, right. If I explain you again, 0 1 2 3 0 1 2, if we are at this index, let's say, right, so down it will be what, it will be plus 1 and 0, right, plus 1 in the row, column will be same, and for this right we are increasing the column, row will be same, right. And here we are decreasing the column, minus 1, here we are decreasing the row, right. So these are the directions. So this is for down, this is for left, sorry, right, this is for left, this is for up, right. So let's write it here. For 1 and 0, it's what, down, one direction completed. Second is, let's say we are going up, minus 1 0, it's up, then we are going in the right, so plus in the column, and this is what, right. And same with the last one, that is what, 0 comma minus 1, we are decreasing the column, that means the previous element in the same row, that is what, left, right. So these are the directions. Now what we need to do next, we are making this subset, this current element as visited, right, for which we are traversing for the next 4 directions. First we will make this row and column as true, yes, correct. We are making this cell as visited. Now let's traverse the directions, int dir directions. What we need to do now, so we will be having the next row, next column using these directions. So next row will be what, row plus dir of 0, int next column will be what, column, the initial column, plus dir of 1, that is column, and we will be having this character, right, either we are going down, up, right or left. So char let's say move is equal to what, let's convert it into the char, and this is what, dir of 3, right? This is string, we are converting into the char. Got it? Now what else? We will do what? Okay, now we need to first validate the next element as valid or not, right? For validation, what are the parameters? It should be in the bound, it should not be visited, it should not be blocked, right? So let's write the if condition for that. If the next row is greater than equal to 0, right? And the next row should be less than n. Same with column. Next column should be greater than equal to 0, should be less than n, and what else? It should not be visited, right? So visited nahi hona chahiye, that means new row, it should not be visited, right? What is the last condition? This should be free, the path should be free, right? So the cell value should be 1, right? That means the maze, right, next row, next column should be equal to 1. So these are the conditions for proceeding further, right? Now what we will do, we will call the same function backtrack with the new row with new indices, right? New row, new column, right? And what else? Maze will be same, n will be same. Now path we need to change, right? We will do what? Path plus c, not c, this move, right? We will be adding the current move in this path. That means we are updating the path. Let's say we are at here it's d, right? Path is d, down. Now we are going again down, so we will be adding plus d. This is the downward position, so we are adding d, correct? And when we will backtrack, when let's say we are going back, automatically this will be removed. Why? Because this is in the call, right? If you see, this is in the call. If we are going further, going back means what? We are at the previous call. That means we are for the path, right? Call is for the path, not path plus this current move, right? I hope it's clear. Okay, path plus move. Then what's next? Visited, correct? And the last one was the result, right? That's it, right? So this is how we will be completing the all 4 directions for each of the cell, right? And then when we will backtrack, we need to do what? We need to make the visited for this row and column as false. That's it. And here I think we need to return the res. Let's run this. Runtime error. What is the error? Out of bound. We are not checking this condition, huh? We are checking the conditions now. That's the issue, man. It's accepted now. Okay, so it was my mistake. I think it's clear for everyone. This is the solution. We are checking all of the 4 directions, and then when we are getting the path, the correct path, when we reach the last position, right, the last cell, then we are returning, and we can say our one call is completed. Then we will do what? We will backtrack it, right? So we will remove the element, right? It will be automatically removed from the call, and we are making that visited as false. So what is the time complexity here? This backtracking will take what? In the last question, for every call we are having two options, right? Either we are taking or not taking. But here we are checking the four conditions, right? We are having four directions. So we are checking the four conditions at each level, right? So if you see, we will be having what? For every call, let's say this is one call, we are at 0, 0. Now we will be having another four call, right? That is up, down, right and left. And for this also again we are having four calls, up, down, right and left, and so on. So the time complexity will be 4 raised to power n, right? This will be the time complexity, where n is the total number of elements in this grid, that is n square. This will be the time complexity. And the space, what about space? We are using one visited array, right? That is checking what? N square. And what will be the space for recursive stack? Recursive stack, again it will be n square, right, in the worst case. So overall it will be n square only.